It's a student budget.
So it's
more and more.
So this is the standard which will be published or is published. I have not checked it yet. So FDIS means final decision. So this is not the published one which will be published, but this one will be exactly the same as the one which will be published soon. So maybe just for telling you that there are different standards for air heater testing. So ASHRAE has a version. Actually, this one will be not published anymore because the Europeans will go to the ISO standard, and I guess it will not be number 2014. It will be number 2013. So there's another CSA standard, and the standards not only say they don't only you will get that. Yeah.
I'm just putting on my camera so I can remember.
Maybe even the draft, huh?
No, not the draft. Because it says listed to a certain person and they gave it to me, and so I already got it unofficially, so so I can't share that. So what they not only test is the thermal efficiency, they test also the incident angle modifier. This is what we already talked about, what is not possible indoors. So you see that that's tested in all of the standards. What they don't test is the collector capacity, or determine that. The collector capacity means actually ranking on how many materials there are and which material has which thermal capacity in order to rank if it's a good collector or not a good collector, but a collector which has a high thermal capacity or low thermal capacity. Actually, it's a bit funny. There are three different ways to determine the thermal capacity. One is, for example, putting the collector in the sun, having a cover that it does not illuminate that, having it on a certain temperature level, taking the cover away, and then wait the time till it stabilizes. So this is one way of, I like that way, but nobody does it that way. Because it's an additional test. What everybody does is, and the standard allows that, having a list of the materials and then adding some factors for each material and then sum this up. Both is possible, both cannot be compared at all. So if one laboratory does it like that way, the other like that way, you cannot compare it. So this is why I don't like that, but yeah. So internal pressure is actually is a test where you try what pressure inside of the collector can withstand. There are some others. If we have time tomorrow, I will go through all the tests because I like that. It's pretty interesting what can happen with collectors. These are also the movies I've bought. But you see, it's depending on which standard you are and which things have to be tested. This also means for some markets some tests are needed. For other markets you don't need tests. What everybody is testing is the leakage of the collector. So how much air goes in or out the collector, in and out the collector, which you don't predict. Then the pressure drop over the collector, this is also tested by all of the standards, and they all make a final inspection. So, for example, opening the collector and see what happened during the tests, right? So, just seeing if anything was damaged, something like that. There are also some standards which allow covered testing, or glazed testing, and the other unglazed. So with the ASHRAE standard, for example, it's not possible to test unglazed collectors with the CSA and the new ISO standard, it will be possible to test that. Actually, these things are based on a white paper from the International Energy Agency, which I will share. I've not made the source over here, but these are all from this paper from the International Energy Agency. So these are the shapes of the collectors they define. So we already talked about covered and uncovered collectors. So these A21 to A3 and B1 to B3, these are all considered as covered collectors, and these are or glazed collectors, and A4 and B4 are unglazed collectors. So this is how the standard would treat the collectors. So if you go, for example, for solar wall, like this one, this would be an unglazed, would be treated like an unglazed collector. And all these collectors here, they are all made for, when I'm right, yeah, B1 to B5 is made for, also made for closed loop systems. Okay, we already talked about the boundary conditions for the air collector and the glazed collectors. The irradiance is the same, surrounding air temperature. The fluctuation of the mass flow rate is a bit different. So what we learned for water collectors, the deviation which is allowed is plus minus 1%. What for air heating collectors is plus minus 2%. I don't know what is with unglazed air collectors actually. I guess they also would allow 2%. So the fluid temperature at the fluctuation is here 0.1 Kelvin. Here it is plus minus 1.5 Kelvin. That's especially important if you go for outdoor solar air collector testing. And for here, that's the same at the outlet of the collector. That's so the deviations which are allowed are way higher than for water collectors. Actually, it's just because it's harder to heat air in a certain level than to heat water. So this is how the open loop circuit is designed. That's actually more or less the same. Like we have that, the fan in the back, the pressure gauge here. But we have some more pressure sensors. Actually, just we need that for the determination of the differential pressure. They have an ambient pressure sensor. They have the humidity. They have the pyranometer. This is the collector, and this is the pressure after the collector at the collector outlet. This is the green hose we connected today. What they do for closed loop circuits, they say we need two mass flow sensors. So one in front of the collector, one in the back of the collector. You have two fans, one blowing wind in the collector, one sucking. Actually, this setup, as we don't have two fans and we just have one volume flow sensor, the setup would not be the same for you. You would just like connect the in a closed, really closed loop. Actually, the one is Fraunhofer is the one is Fraunhofer is also a closed loop in the end. But what they try to do is you have a under pressure on this side, right? If the collector, the fan sucks air from here, and you will have overpressure over here if it blows in here. And what they try to do is to get at the position 5, like in the center of the collector, they try to reach the ambient pressure in order to have the least leaking rate of the collector possible. So this is why they use two fans. So actually, this is how we designed our closed loop system. The standard in that time was not ready, so this is the way we designed it back then. So this is our mass flow meter. Here's our frequency transformer. This would be the air-water heat exchanger. So you would collect the temperature of the collector in to the heat exchanger, and here's the temperature of the collector out in order to set the temperature of the water-air heat exchanger and the air in the end, you will have a gap, right? There will be a gap because of the heat exchange rate of the heat exchanger, but as I told you, it's not really important if you set the temperature at 20 or 15 degree. In the end, it's needed to have a temperature variation over the working point. So get to 40, 45, 20, 40, 60, 80 could also be go to 25, 45, 75, 95. So it does not really matter in the end because you will fit your efficiency curve anyway. So what we have also is that we measure the pressure drop of the collector, so inlet and outlet. We have also an ambient sensor and all our other pressure sensors are related to this barometric air pressure. You see, in order to know all of the every point of the circuit, in order to know always the pressure from out of the room related to the pressure in the circuit, we all reference on this room pressure. So this is connected in order to know what is the reference to the inlet and what's the reference to the outlet, and the same is true here for the mass flow. That's also, these plans are also in the other thing. So this is how the standard says the sensor should look like having a temperature sensor of in all the tube, and this is how yours looks like. So very close to what the standard wants, because we already knew that this will be how the standard is designed, but for the other thing we didn't know that. Oh, I'm sorry. I have not cut the picture because these are the pictures from the standard.
She made the standard.
Yes, the standard. Could use the snipping tool.
It was late yesterday evening when I made that. So, actually, in the paper I will send you, they compared two different methods. Having an air blender in order to homogenize the temperature, like having something which is mixing the temperature. I think it's called blender, air blender. But the problem with these things is mostly
Go over there to be absolutely
if you have
sure.
installed that over here and you vary your mass flow, it's depending on
So 3 out of 4.
the distance, x is varying. So if the mass flow is getting
Oh, they're all
higher,
right. It's just
the homogeneous
noise,
temperature will be here.
Oh, I see.
If it's getting lower, it's here. So they compared these two methods. So to have this fine mesh things, like this grid thing. So having the temperature sensor here, and then before having this mesh, they compared these two methods, and they found out having these two fine meshes gives you the better result. I'm not 100% familiar with that. I just want to state that this is the one they suggest in the standard, and in the paper I will share with you. They're discussing more.
When you say fine mesh, how large is the?
I don't
I
know.
mean-
The standard does not tell you that.
Window
Just get
fine 1 millimeter or 10 to a millimeter.
Along the
I
check
think
the gap.
2 centimeters
No,
here.
of course,
pretty
not.
fine.
People have something like that.
It's fine.
Yeah, something like that. Like with
How
the
fine
speed.
is fine.
So and they
No.
try to make a turbulence
Yeah.
in order to have a
It's
more even
unusual for
temperature
Europeans not
distribution
stating.
in the duct. So this is why they compared these two methods, like having I think it's called blender,
Something like
and having
that,
this
yeah,
mesh.
to make
and they found out that the mesh thing is the better one.
I think it really
So this
depends
is why
on
the
your
standard
flow rate
now
too. They
suggests
just
to
want
have
to
a
flow,
fine mesh
break up your
to
flow,
after
you have
each
to
other,
resist
each
it,
other, so having
then the air
first
goes
one
smoothly.
and then the second one, and then have the temperature sensor, and then you get a more even temperature distribution. So this was not clear also when we designed that. This is why you don't have a mesh at the moment. You can make your own test if you want, or you leave it like it is.
They just find the brand.
So this is just a picture for why the standard says it's important to vary the mass flow. So here you have we have solar air heating collector is SAHC. With a high mass flow rate, you will see the efficiency is a bit lower, and then you have a medium mass flow rate and a low mass flow rate. So you will see that the efficiency is a different one. This is why they say it is needed to vary the mass flow, and the standard now tells to vary the mass flow in 3 different steps. And I don't know how much it is. I think it's something also with, I don't know, I will check that for tomorrow. It's based on the square meter as well, and then they vary, say, take a low one, a medium one, and a high one, and then they share the ratio with that.
Little green tape.
But you told you are also varying the mass flow, right?
Just not sufficient for 10 bodies.
What are those points?
10 bodies.
Testing points.
That should be what's for 3 meters per second. Wind,
No, you
wind,
still have issues.
uncovered solar air heating collector. This one, it's an uncovered collector. Like
frozen.
I don't know if they put E4 or
And
A4.
your whole,
One of these uncovered collectors.
for, efficiency of
And they varied the wind speed, the average wind speed. So the fan, the wind speed over the collector plane, they varied that for an uncovered collector, and that's the results they got for
Mass
3
speed.
meter
Yeah.
meter per second, 1.5 meter per second, 0 meter per second.
So those they refresh are supposed to mean the efficiency curve.
froze back.
Yeah. That's indicating the efficiency.
Because it looks all over the place.
You have to categorize. Now, when it says the wind speed, does it has we know the wind speed close to the ventilator?
No, the
It's
average,
higher?
it's wind speed. Yeah, sure, but it
It's
is
like
the average wind speed over the
But
collector.
does it have a limit on the span of one is 5 meter, one is 0.5? Does it
No, that's
matter?
it was. I think in that I will share the paper. That's very.
Inside the collector.
So you see, this is from a paper which is very recent, September from this year. So that was for the conference, solar air heating conference.
What is SA?
Solar air heating collector.
Yeah. Thanks, but no
So
thanks.
that means that's the wind speed inside the collector?
No, over outside of the
Outside.
collector.
Over.
Yes. Inside is the mass flow rate, depending on your
It's
design.
Wasn't worth that
It's not
much
a
either.
solar.
I think so. Yes.
Yeah, probably.
We didn't start stealing
Yeah,
these
but I imagine
packages until
cheaper.
about 98.
I will share that.
Oh, is this the one in Mount Concordia University?
Which one?
No, this
No?
is
Task 40? No, it's not Task 40. Task 40 is just part of SHC.
That was
That's in Germany.
That's a conference. That was recently in Freiburg. That conference.
Okay. You can send us a copy?
I will share a copy of the. I will share a copy. I don't know. I have to ask. I have the paper also, but I don't know if it's already published. So I don't know if I can share it already.
Okay. Check it first. Yeah.
Yeah. Yeah.
And also we have
We won't.
somebody is with Task 40 of HSC.
Task 40
Is that my new published?
Net zero energy. Something.
Another paper
I don't know. But
Nice.
maybe there were people over there at the conference. But
Yeah, that should be. There's a lot of German and a lot of other people.
A test.
Homogeneity?
They did that already.
Sensors.
so
Okay, we can access all of this.
yeah, you can access that.
Everything.
So
If it's on
Yeah, this is what I.
Sans Direct, we have everything.
This is why I say I don't know if it's even published yet.
Oh,
So he just sent me the email for the with the information because I said I'm visiting you guys, and then I said, have you some recent papers on what work you have done? So this is why he shared the.
oh, if it's on Sans Direct, I think
No, the problem
not
is that
maybe not. Some of the
if
when
it's not
it's not
published,
full.
we'll not find.
Maybe it's not there.
no,
so
this is already
they-
there, right?
No,
No,
it's,
he got a copy.
I
from
got a
the
copy
author.
from my friend because he wrote the paper.
When he got a copy, it's almost accepted.
You'd think with the letterhead and logo there that it got accepted. That's what
It's,
Oh, this-
yeah, it got accepted, but
Yeah.
Oh,
it's
it's
not
not
published
published.
yet.
No.
So
Can't
Yeah,
scoop
it makes
his own friend.
All right,
Shall
it's
we
just
put on the-
find other bedtime reading.
yeah, sure. We can check if the
You can even
is it
search
ready
right
already?
away.
Is it
I
ready?
don't know. It smells like it's ready.
Yeah, it's at the end of its.